Hello Algodevs! In this video, we're going to learn how to implement the unit testing and the integration testing for our smart contract. Remember, in this series of videos, we're creating a personal bank smart contract. And if you remember the previous videos, we have some different methods. We have the deposit method and we also have the withdraw method. In this deposit method, we need to pass a payment transaction as a parameter. And in the withdraw method, we have an inner transaction where the smart contract is going to send the payment of the algo that has stored in the smart contract account. Let's start with the unit testing. For doing unit testing in Algorand Python, we'll need to use the Algokit Utils Library. If you remember the pseudocode that we saw in a previous video, we have the Algorand context. This context is basically the emulation of the ABN. We're going to be using the context for getting all of the interfaces for creating our unit testing. So let's get started with the fixture, basically the arrangement. First thing we need to do is create the context. So we're associating the context as CTX. And then we're doing two different tests, deposit and the withdraw. If you remember, we were using an arrange, act, assert pattern. That was part of the pseudocode that we saw in the previous video. First thing we need to do is implement or instantiate the contract, which is the personal bank. Remember, this personal bank is basically the interface for the smart contract. Once we deploy the smart contract, we need to get the information of the application. And we're going to use the context.ledger.getUp. Remember, the ledger is the interface for interacting with the ledger data. Part of that data, part of the objects, is the application that we just deployed right here. So we're getting the whole context of the application and the whole information. Then we're generating a random amount of number. This number is a random value generated by the context.any that is going to be used as the parameter for a payment transaction. Remember, in this first test, we're doing a deposit. So we need to send a payment of n algos to the smart contract. Deposit txsend is going to be the variable that will store the payment transaction. So we're using the context.any.txsend.payment. Basically here we're declaring a payment transaction where the receiver is going to be the address of the application we just deployed and the amount is going to be the random number that we just generated right here. Then we're going to get the output of the application call where we're invoking the deposit method. And we're passing as a parameter the payment transaction we just declared here. And the assert is basically going to be comparing the output of this application call and the deposit amount we just generated in a random way, just right here. For the withdraw method, it's going to be something similar. We're going to deploy the smart contract. We're getting the information of the contract from the ledger. We're generating a random amount and we're declaring a payment transaction right here. Then we're calling the deposit method. But then also we're calling the contract.withdraw, the withdraw method. And we're going to compare the output of the withdraw method with the deposit amount. Remember, the withdraw method will return as a result the amount of the algos that the smart contract just sent to the owner, that sent back to the owner. So that's the number we need to compare to a random amount. Because first, we're generating a random amount, and we're sending that number of algos as a deposit, and then we're doing a withdraw. So that's it. That's a very easy and single test for our unit test. Here we're demonstrating how easy it is to use the Algopy test, which is the tool for doing unit testing. If we run the test, we will see that the first test has just passed. And if we run the second test, the same. As you can see here, it was very fast to execute those testing. But if we go to Lora, we'll see that the transactions list is completely empty. It means we haven't sent any transaction to the ledger. That's because we're using an emulation of the ABN. We're not sending real transactions. We're using unit testing with the Algopy test context, which is emulating the ABN. And it's really fast. You don't have to wait for any kind of response from the ledger, and you will create like isolated logic testing. But now let's go to the integration testing. We're going to uncomment this and let's take a look. First, we have the imports here And then we're creating a deployer account. This deployer account is going to be the account that is going to deploy our smart contract. As you can see here, we're creating a new account from the environment and we're funding this new account. So this is an extra step. In the unit testing, we don't have to deal with the funding or the fees or paying any kind of amounts for the transactions because this is an emulation. But in this case, we're using the real network. After that, we have to create a depositor. Depositor is going to be the account that is going to send the funds to the smart contract. And it's going to be the same, creating the account using the Algorand client, that account for environment, and we need to send some funds to this new account. And then we need to create the personal bank client, which is basically the smart contract interface or the client that is going to be interacting with the smart contract from the ledger. So we're using a factory here for creating our smart contract, for deploying it, and we're going to implement the client right here after creating the smart contract. Then we're going to dispenser because we need to fund the smart contract because the smart contract will need to pay some fees and needs to be active and needs to make some inner transaction. So here we're making sure that our smart contract will be completely funded. And then we have the real test. We have the deposit test and we have the withdrawal test. It's the same test for the unit testing, but the main difference is that here we have to deal with real parameters, with real fees, with real interaction with the network. First thing we need to do, if you remember, our smart contract says that for calling the deposit method, we need to create a payment transaction, just like we did for the unit testing right here. So we're going to instantiate a new transaction. We're going to use the Algorand client that create transaction, that payment, and we're going to use the payment parameters. We're going to specify the sender is the depositor address, the receiver is going to be the smart contract, and the amount is going to be 1 algo. Then we're going to call the smart contract, the method deposit, passing as an argument the payment transaction and specifying that the account that is calling the application is the depositor with an extra fee of 1000 microalgos. And the result from calling the method should be 1 million, which is basically 1 algos or 1 million microalgos. So if we run this test, we will see that it's completely passed, so it's completely correct. We just created a first integration test. The main difference is that if we go now to Lora, we will see different transactions here. Let's take a look in detail. The first transaction is going to be one payment transaction, which should be the payment for funding the first account. The second block is going to be another payment transaction where we funded the account for the depositor. The first one was for the deployer. As you can see here, we funded the deployer and now we funded the depositor. The third block is going to be the application call. As you can see here, it's a creation of an application. It's basically the deploying of the personal bank contract. The next block is going to be a transaction of a payment where we're funding the application address. And it's this one here. So the next block should contain the transactions for this test. The only transaction that we just made is deposit call. That includes another transaction, which is the payment transaction. So let's take a look. If we go here, we can see two different transactions, the payment transaction and the application call. And this is part of a group of transactions, which is basically one payment transaction and one application call. So that's it. As you can see here, that's the main difference. If we go to the withdraw, it's going to be very similar. We need to call the withdraw method, but we need to specify the max fee, which is going to be for calling the application that is going to include the fees for the inner transaction. And we need to specify that our transaction call or application call is going to cover the inner transactions. Remember, previously we just sent 1 million microalgos or 1 algo, and now that we're calling the withdraw method, we should receive 1 million of microalgos back. So that's what we're comparing here. That's the assert right here. Let's run all of the tests now. If you go to terminal and you type Algokit project random test, it's going to run all of the tests, the unit and the integration test. So it's completely run, it's completely correct, everything right now. And if we go again to Lora, we'll find some new transactions as well. Transactions for the first one that we just saw, transaction for the application call, a new creation, another transaction for the payment of the new smart contract, the transactions for the deposit method, and the transaction for the withdraw test, which is right here, where we called the application and the application sent back the payment of 1 algos. So as you can see here, this is the main difference. Maybe in the pseudocode you notice that the integration test seems a little bit shorter, but at the end, in the implementation, it needs to fill some extra requirements to execute the transactions. Because remember, in unit testing, using algopy testing, we're using an emulation of the AVN, so we're not doing real transactions. But when we're doing integration testing, we're executing real transactions to the ledger. So there are the main differences. I hope you like this video, and remember, testing is an important part of the smart contract development. So don't forget about creating your unit and integration testing.